Kia ora team, welcome to my favourite multiplication strategy. I love decomposition. It's my go-to strategy whenever there are big numbers involved. Okay, you can use known facts like we did in the last video to solve these sorts of problems as well, but I personally prefer decomposition. A really good mathematician needs to have lots of tools in their toolkit. So it's no good just learning one multiplication strategy and hoping that it will work all the time for everything. Yeah, you can use doubling trees for every single multiplication problem, but it's not always the most efficient way. You can probably use decomposition as well, but it's not always the most efficient way either. This is one of the reasons why we learn so many different ways to tackle problems. That way, if you're ever stuck with a really confusing problem, you've got lots of tools in your toolbox to have a go, rather than just one. Rightio, let's get into decomposition. You'll know it's a good problem for decomposition when one of the numbers is quite big. Let's have a go at 4 times 28. Now straight away I know that I don't know my 28 times tables. And I know that I could use a doubling tree, but I don't really want to write out 4 28 times. That will take me forever. I could use a known fact here, but in this case, I think the most efficient strategy is using decomposition. What we are going to do is we are going to decompose the number 28 into its parts, like PVP. So if I draw 28 in a place value house, how many 10s and how many 1s? There are 2 10s and 8 1s. So what I'm going to do is I'm going to write out my problem broken up into its parts. 4 times 20 and 4 times 8. Right, now all of a sudden it's a lot easier. What is 4 times 20? Well, I know that 4 times 2 is 8. Yeah, 4 times 2 is 8. So therefore 4 times 20 must be 80, because I just add the 0. 4 times 8, I could skip count that if you like. Or you may just know the fact. 4 times 8 is 32. I know the fact. This is why it's really helpful if you know your basic facts from extra maths, because you'll be able to solve these sorts of problems so much quicker. But I could have counted it out as well. 8, 16, etc. Right? Until I get to 32. Alright, or even in 4s. 4, 8, 12, so on until you get to 32. Right, the last step is to add these together. I'm going to use working form, because I think that's the quickest way in this case. 0 plus 2 is 2, and 8 plus 3, 8, 9, 10, 11. So my answer is 112. 4 times 28 is 112. Alrighty-o, let's try another one. Let's try 6 times 54. Now straight away that's a massive number, 54, and so you might freak out. But don't freak out, okay? We can solve this using our decomposition strategy. Let's decompose 54. 54 is made up of 50 and 4. So I'm going to write out the problem again in its parts. 6 times 50 and 6 times 4. Rightio, now we solve each part on its own. What is 6 times 50? I don't know, but I do know what 6 times 5 is. I could skip count 6 5 times. 6, 12, 18, 24, 30, 36. Hang on, I skip counted that wrong. 1 second. Let me try that again. 6, 12, 18, 24, 30. Got it right that time, Mr. Kago. 6 times 5 is 30, not 36. That's 6 times 6. Okay, so if I know that 6 times 5 is 30, then 6 times 50 must be 300. I just take that extra 0 and I put it on the end of the 30. Alright, so 6 times 50 is 300, and what is 6 times 4? 6, 12, 18, 24. Alrighty, now I just need to combine the parts back together. 300 and 24, that's easy, I don't even need to add it up. It's just 324. Okay, so 6 times 54, our answer in there. This is how we use the strategy of decomposition. And like I said, it's the easiest strategy that I can think of for solving large multiplication problems. 324 is my answer here. you can use this even if it's larger digits. So you can equally solve this same sort of thing with 6 times 254. It's really not that hard. What's 6 times 200? What's 6 times 50? And what's 6 times 4? Well, 6 times 2 is 12. And we just put the extra 2 zeros on this time. 6 times 50, we just worked that out. That was 300. And 6 times 4 is 24. Now we solve. 1,200 plus 300 is 1,500, and then the 24 on the end. Really quickly, I just solved a really massive multiplication problem inside my head. Alright, 1,524. Okay, so what I want you to do now is I want you to go onto the follow-up activity, and I want you to have a go at decomposing the problems. You'll need to do your working on a piece of paper. And if you already know the basic facts, then you're going to be even quicker at this. All right? And if you don't know the basic facts, this is why us teachers keep telling you to learn your times tables. If you can master your times tables, problems like this, which you're going to get more and more of in year 7 and 8, are going to be easier and easier because you already know your basic facts. Okay? We don't just say it because we're mean, nasty dragons. We really want you to be able to learn them so that it's easier for you in the long run. Okay, kia kaha guys, good luck, and I will see you later. Bye-bye.